this is one of my absolute favorite trig laws here, the law of cosines. It's a very basic formula to use. It's not hard to even accidentally memorize it, as you use it. So what we're going to do is, instead of focusing on the law of sines with angle, angle, side, and angle, side, angle, and the ambiguous case side, side, angle, what if we get a nice case of side, angle, side, and side, side, side? Now, again, what that means is everybody in the class draws the triangle. It has to be drawn the same way because there's a congruence going on there that you learned about in geometry. So Anthony drawing one and Kaylee drawing one, they're going to get the exact same triangle. They may not have the A's and the B's and C's in the same spot because they might, move it around a little bit. But in the end, all of the sides will be the same length and all of the angles will be congruent. And then what we want to do is learn how to find the area of triangles with a special area formula. Pretty obviously, you already know area equals 1/2 base times height for triangles. But in a special situation where we have side, angle, side, or side, 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 we have a great little compact formula for finding the area of a triangle. The law of cosines says, let triangle ABC be any triangle with sides and angles labeled in the usual way. So you got a capital A, and across from that you have a lowercase a. Then a squared, missing side here, equals b squared plus c squared minus 2bc cosine of a. How is that easy to memorize? Well, first of all, look at what it starts and ends with. And then look at the letters that are used for everything in between. So, starts with A, ends with angle A, and then B's and C's in between. This one is built for b squared. B squared equals a squared plus c squared minus 2ac cosine b. Same thing. Starts and ends with the b, but everything else in between, a's and c's. This one is all about c. And they all work that same way, where what we start with and what we end with is the angle and the side opposite that angle. And everything in between is about the other two side lengths. And notice it's the law of cosines, so we have cosine in every single one of these now. Now, why not, if this is an easy one and that's easy to memorize, why not use this for what we did in the law of sines? Because we can't. It's a different situation. You run into that, you're going through homework problems and you're thinking, oh, I can use the law of sines for all of these, and all of a sudden, I don't have angle, side, angle. I don't have angle, angle, side. I don't have side, side, angle. I have other circumstances. So we have to look at the triangle and say, what parts do we have, and figure out whether or not the law of sines and the law of cosines would be the best way to go. So looking at this one, right away it says solving a triangle, side, angle, side. That's probably not going to happen in your homework, where they're flat out going to tell you what it is. So you go over here and you take a look and you see side, and yeah, this 20 should be up here, but they want you to be able to see it. So side, angle, side. Can't use the law of sines. I've got to start somewhere else. And we have this triangle given lowercase a, which they already have labeled on there as 11, lowercase b is 5, and then c as 20 degrees. So here's my focus. Angle C. That's the one I have. So I want to use the formula that's going to give me something about angle C. So that means I'm going to have to end with cosine of 20 degrees down there. But while I'm thinking about it, I realize, well, that means this is going to be a little c squared over here. And that's the only place the c's are going to show up. So it's going to be a squared plus b squared minus 2ab cosine of c. Now we're going to give you those formulas, so you don't have to memorize it. But it does make the work go a lot faster if you do know that piece. All right. Well, let's see. That will allow me to find C because I know what A and B are. They gave me those. Those are 11 and 5. So this will be 11 squared plus 5 squared minus 2 times 11 times 5. This is basically just a bunch it in problem. I've got it in the formula and everything's ready to go. So anybody going to need to borrow a calculator today? Because we're definitely doing a lot of stuff with it. calculator as we go through things again today. All right. Sure it isn't switch this out of degree mode, which again, MCA takers, juniors, you want to make sure if you're going to use that pop-up calculator on the MCA, make sure that you reset it to degrees, because every time you quit using it, it goes right back to radians. And we need to do 11 squared plus 5 squared minus, and then I always put parentheses to group all of that together for the calculator. 2 times 11 times 5 times the cosine of 20 degrees. And that's c squared. Now, because that's like the only step of work that you could show besides the answer if you want your answer exact, this is the one rare time that we're going to tell you it's okay to put square root of that monster up here to 3 decimal places. Because that helps us when we're grading to know you were exactly where you were supposed to be, but if something gets messed up in that last step, we could just take a half a point off or something for not doing the square root correctly. And then that's all we do is square root that answer. So second square root, second negative, and there it is. Little c is about 6.529. Chances are pretty good that I'm going to need that for something else. So I'm going to go ahead and store this, and I'm just going to store it in x again. So store alpha x. And it's sitting there and waiting for me. Like so. Because I realize it said solve the triangle. That means I need to know what the other 2 angles are. I only have 1. So I'm going to have to figure out how I could use the law of cosines again to figure out one of these angle measures. So what I need to do is just pick one and go with it. I have that one stored in there perfect, so technically I could use it, but I'd feel a lot safer using the numbers that they gave me. So if I can use maybe just B here, obviously C is going to be involved. But you just decide whether or not you want to do B first or A first, and you'll end up having to use that math that you're doing there. So we might as well just go in alphabetical order. Find A. So if I need A, start with the opposite side from A, which would be lowercase a squared. B's and C's in between. And then the cosine of A in the end. And I realize I'm trying to figure out what A is. So if I'm trying to figure out A, I might want to just build this formula right now to give me the angle. So I'm going to subtract B squared and C squared and divide by negative 2BC. And that would get me the cosine of the angle. And then I could just take the inverse cosine and have what I need. So we'll put the numbers in. And our A value, let me back up here, is 11, and B was 5, and we did math for C. So 11 squared minus 5 squared minus our 6.529 squared divided by negative 2 times 5 times 6.529, and we're going to take the inverse cosine of that to get the measure of angle A. So let's see what happens. 11 squared minus 5 squared minus, remember we stored that in x, so alpha x squared. And I put all of that in parentheses so the calculator knows everything on top, divided by parentheses, negative 2 times 5 times x. And now I just need the inverse cosine of that. So second cosine of our answer. And And there we are, 144.817 degrees. Now, I still need that to find the third angle, but the good news is every triangle has 180 degrees in it, so now it's just going to be some subtraction. So I'm going to go ahead and store over the top of that X and put this one in here now, just so that everything comes out and there's no rounding error. There we go. So we are still looking for B, the measure of angle B. And that'll be 180 degrees minus the one that they gave us, which was 20 degrees, minus the one we just found. And we'll have it. So 180 minus 20, well, 160, I could just punch that in, minus X. And there it is, about 15.183 degrees. And then again, probably go back and put them in a box. All the good information that we found as we went through there. Because we had 3 pieces of information. There's a total of 6 in the triangle. There's the other 3. And we have. Now, at some point, we have enough information when we have 2 angles to use angle, angle, side, or angle, side, angle. So the question becomes, you know, after this, why wouldn't you just use, once you find one of the other angles, why not just use the law of sides? I mean, it was so nice and easy with the proportions and all of that. That's because the sine function is odd. And so it doesn't know the difference between a positive angle and a negative angle. But with cosine, it's even. And by being even, cosine recognizes when you have a positive angle versus a negative angle. And that's what this little paragraph, which is kind of teeny down here, says. Note, we can now use either the law of cosines or the law of sines to find one of those last 2 unknown angles. As a general rule, always better to use the law of cosines to find angles, since the inverse arc cosine function distinguishes between obtuse angles and acute angles. Sine doesn't do that. And that's all because it's odd. So any angle in its supplement will have the same sine value. It doesn't know the difference. We would have to do extra math. We don't want to do that. So if you can, you stick with the law of cosines. All right, next page. We have another solving a triangle. And this one is in side, side, side. So what are we really trying to find here? Angles, all 3 angles. So might as well go in alphabetical order and say, all right, well, I'll start with angle A. So A squared equals B squared plus C squared minus 2BC cosine of angle A. And again, it's really helpful to just start off by saying, I'm going to build this so that I can find A right away. You know, I don't want to put all the numbers in there and then have to show the step where I put everything back over to the other side. So right now we'll subtract the B squared and the C squared, divide by the negative 2BC, and that'll equal the cosine of A. You could do it the other way. You could put the numbers in, then move everything over, but like I said, it's just kind of an extra step and a waste of your time. So what we're going to want to do is get the inverse cosine once we put all those numbers in. And we have them either right here or over in the drawing. So we'll have 9 squared minus 7 squared minus 5 squared divided by negative 2 times 7 times 5. And that will get us the measure of angle A. Punched absolutely everything in there so we can see it. And then inverse cosine And we have our angle A, 95.739 degrees. Enough of us for us to just start subtracting from 180? No. So I'm going to have to do this at least one more time. I'm just going to stick with alphabetical order. Are we going to need to use this to find B? So we don't need to store it this time. We have no use for this angle when we're trying to find the other ones. So B squared equals A squared plus C squared minus 2AC. Cosine of B. Again, I just move everything over. And then the hardest part is just keeping everything straight and getting everything in there. And actually, I'll move this over and do inverse cosine right now. So back up there to B squared, which was a 7. A was a 9. C is a 5. Over negative 2 times A times C, so 9 times 5. And we'll inverse cosine that. .704 degrees. So now we have two things to think about first. Could we have stored that one? Yeah, we absolutely could have stored both of these in there and done 180 minus these two answers that we have. But the lab cosines is not such a bad way to find the last one either. We won't really have a rounding error if we rounded correctly as we go through this. So we could just take 180 minus the two answers we have, and everything will be just fine. We're not really using them for calculations. Just subtraction. That's all. So there's our last one, 33.557 degrees. If you're worried about the rounding error, then yeah, you store 1 in x, store 1 in y, and then do 180 minus x minus y. But at the end, if we've rounded the other two correctly, this third one absolutely should be correct as we go through it. So just on the law of cosines, 43210. Yeah, the one thing about the law of cosines is always bothered me is, do you see how you're handing the trust over to the calculator completely? Yeah. And you've seen me punch stuff in before. I punch things in wrong all the time. So, you just kind of double check, does this make sense with all the other answers that I get here, and go for it. So we truly do just hand it over to the calculator and say, whatever you tell us, calculator, we're going to agree with it. So next up, triangle area adherence formula. Back when you were doing geometry, you didn't get the toughest triangles in the world to find the area of, Normally you got the base and the height, and you did your 1/2 base times height. Sometimes when you got into the trig, yeah, you had to figure out what the height was and then put it into the area equals 1/2 base times height formula. Well, somewhere along the way, somebody got really sick of doing that and said, wouldn't there be a different way, a nicer formula, and found a really nice one for certain situations. Triangle area adherence formula says the same parts that determine a triangle obviously also determine its area. How many square inches, square feet, square units is it going to take up? If the parts happen to be two sides and an included angle, side angle, side, we get a very simple area formula in terms of those three parts that does not require finding an altitude. ACTs every time. Here's why. This problem would take you, any problem that doesn't give you a nice height or nice numbers is going to take you a lot of time to do by old-fashioned trig methods. So they'll put an area problem on there with side angle side, and they'll know immediately whether or not you're a student that has gotten to that level of math. Because you're not going to use 1/2 base times height if you see side angle side when you have an incredibly easy formula for that. This is just plug it in. They're going to give you those two sides and the angle in between. You plug it in, make sure you're in degrees, and bam, you have the answer and you move on. So it's one of the ways that they tell, how far did this student get in math is by this problem. But it only works, unfortunately, side angle side. So this is called Heron's formula. And it says find the area of a regular polygon. So we're taking this up a step and we're saying find the area of a regular octagon. Well, that's because way back in geometry you learned that you could form 8 little triangles that would all be exactly the same, and that would give you an octagon. But what we have so far is this. And I'm over-exaggerating that so that you can see my drawing there. But we need to know what theta is. So the key to that is knowing if I travel all the way around inside that circle, how far have I gone? 360 degrees. And if this is a regular octagon, all 8 of these triangles will have the same little angle right up there. So if we take 360 and we divide it by 8, we're going to have the angle right. So, seems to me we've been doing that a lot with the unit circle. What angle gets formed? 45-degree angle. So this is 45 degrees, which makes this a perfect problem for Heron's formula. So 1/2 9 times 9 times the sine of 45 degrees. Punch it in again. And again, we do know the sine of 45 degrees exact, so if we really wanted to, we wouldn't have to punch in the sine of 45 degrees. Gives us that. And did we know units here? Inches, so square inches. But we're not done yet. How many triangles we're going to fit in there? So we need 8 of those. There it is, 229.103 square inches. Like I said, on the ACTs, it's one little triangle. Here, we're handing you everything. You know what you're doing, plug it in, boom, you have the area, and you walk away. It's a very, very, very nice formula to be able to use. Speaking of other nice formulas, here's another one with Heron's formula. So let A, B, and C be the sides of triangle ABC, and let S denote what's called the semi-perimeter. And you've never probably worked with that before. I think in geometry, the only way they teach that is like if you've gone way above what it is you had to do, you've gone through the whole book, and they have extra time. So semi-perimeter is just, you find the perimeter, and you divide it by 2. And that's S. And then you can use Heron's formula to figure out the area. So the other formula we had, beautiful formula for side angle side. This one is a beautiful formula for side, side, side. So another way to find the area. And this one, I don't know if it's something you remember when you take an ACTs. It's not something that's intuitive. It's a formula that's been developed over time. So the square root of the semi-perimeter, and then what you do is you're comparing your sides A, B, and C to that semi-perimeter all the way through the formula. And that'll get you an area of the triangle. So we need to find S. It's not a hard thing to do. 13 plus 15 plus 18 divided by 2. Little 23 for S. So area equals square root of. We start with S, and then we compare the 3 side lengths that we have to that 23, and to compare, what we do is we find the difference. So we have 23 minus 13, 23 minus 15, and 23 minus 18. And to me, it just makes sense to do the little bit of subtraction in there. Now, 23 minus 13 is going to be 10. 23 minus 15, 8. 23 minus 18, 5. Makes it a little bit easier to punch in. But I'm going to do all the multiplication first anyway, and then take the square root of that answer. So 95.917. And we did not get anything for units here, huh? So just square units. Let me do that one. That was as far as we hit yet today. How do you feel about the last two formulas for areas of a triangle? 4, 3, 2, 1. Nice formulas. They're one of those formulas where you go, man, I wish we knew this formula before, but just in time for the MCA, so that's good. So, and I'm going to record this while I'm talking about it, while the people that are gone can hear what I'm going to say here. Next week is the Goofy Week. Juniors, don't forget, charged Chromebooks. Make sure that you're changing everything in degrees if you have to use their pop-up calculator. And for anything with percentages, dealing with probability, you have to put it in as a decimal or as a fraction. That's the only way it's going to take it to give you credit for your answer. How everything is going to work next week is this. We still have a second day of 5, 6 to do. So I'm going to have to make a video lesson for that. And juniors, I'm going to do it tomorrow so that if you don't want that hanging over your head while you're trying to take the MCAs next week, you could just do it this weekend and have it out of the way. Everybody else, you're going to have 2-hour study halls when you're supposed to have this class. In fact, we're going to stay in here. So non-juniors are going to stay in here and we'll have a study hall. There'll be some other students coming in from other classes that will have study hall in here with us. Juniors, I'll be sending you to Mr. Michener's room to take your test, your MCA test. And then Wednesday is up in the air. We're not sure whether or not everybody's going to be able to finish the test during a 2-hour block, either Monday or Tuesday, because as they have every year, they changed the MCAs again this year. They are not all multiple choice anymore. Some of them are drag and drop. And so we're not sure if that's going to take students a lot longer to do or what's going to happen. So that means I'm going to have to give you our review assignment as well, as a just in case we're not having actual class on Wednesday. But please don't do it this weekend and go 4 days without looking at math before we take the test.
So we have 2-hour study days.
We do. First, third, and fifth hour finals block type of thing. Yeah. First, third, and fifth hour on Monday, 2, 4, and 6 on Tuesday. Oh, probably just first lunch. They haven't sent anything out yet, which makes me think that because math usually has first lunch, that we're just supposed to have everybody go to first lunch. But we're coming to class first because lunch doesn't occur when the classes are staggered for block schedule. So it is just like finals, where you go to class for a while, then we'll have lunch, and then we'll have class again. So if you're not a junior, make sure you have plenty to keep you busy, while you're supposed to be having a study hall. Juniors, charge up those Chromebooks, have everything set. Let me get you the assignment from what we've been doing so far. And then I need to get you the review assignment just in case somebody's not done with the MCA test and we still have to go on with the study hall thing. And then we forgot to type in one thing on the sheet that I'm going to have you add. Rather than run it again. We decided we calculus students will listen if we cover something like that. So there will be, well, you might wanna just write that one down while you're here too. This will be, everybody, you've got the white sheets, got out to everybody. Maybe put your name on it in case you accidentally leave it somewhere. I'll get that back to you. But, you see the three problems in the middle there? E sub 1, it was supposed to be extra 1, extra 2, extra 3. The directions on the test, we wanted them to match the directions that we had when we went through the notes. So we want to put next to those, even though normally we just say find all the solutions. Reminder, the stuff from the notes said find all the solutions from 0 to 2 pi. So we want to stay consistently with what you guys have seen for the notes and the lesson and everything.
Or do you have to put to show the whole formula thing, or can you just know off the solution?
To grade it, I have to have a way to see where they're coming from. So it would be best, it would be best and probably easiest for you to just do it the way that we did them in class when we went through the notes for the examples. Because what Ben's saying here, and I talked to Ben a little bit about this before, the 3x can be broken up into x plus 2x. And then you could just use the identities and the formulas that we've had before, and you could solve all of these without having to use the 3x equals at the end and find the solutions. There's more than one way to do these. But it might take a little too long for you, and you might not have enough time to finish the whole test if we were to do it that way. Okay? So, shut this off.